Okay, now let's talk about discounting. And the book calls this, or it deals with the time value of money. And the basic idea is that money in the future is worth less than money today. So we can think about this in terms of opportunity cost. Okay, and the opportunity cost of getting $1 in the future is the money that could have been earned in interest if the dollar was received today. And business managers use present value analysis to make decisions when comparing benefits or receipts or revenue with expenditures that happen at different times. Some happen now, some happen in the near future, some happen in the distant future. Okay, so the present value calculation is based on this formula. So imagine we have a single future value that happens in year N. Okay, so if you receive a future value in year N, you would discount that by the denominator of this fraction, 1 plus the interest rate or the discount rate raised to the power of N. And the present value is going to be less than the future value, and the difference can be considered the opportunity cost of waiting. Okay, so if you have a stream of future values, you just add up those present value formulas for each year that you receive those values. So if in year 1, which would be next year, right now is year 0. Okay, if in year 1 you receive future value sub 1, then you apply the present value formula, and then in year 2, apply the present value formula for amount FV sub 2, and then the denominator is raised to the power of 2, and you keep doing that until you reach the end of the decision period, time N. And so this notation down here says the present value is equal to the sum of the discounted future values added up over years 1 through N. All right, and the book likes to do these examples, and they call it inaction. It's because it sounds exciting when you say that. Okay, so imagine a business is considering a project that would generate revenues in year 1 of $10,000, year 2, $50,000, year 3, $100,000. And if the interest rate is 3%, the present value is going to be equal to $148,000. Okay, and you can see from the present value formula, you just plug in those values and do the math, and you reach the number on the second line. Okay, so that might be the stream of benefits. And if you're making a decision, there's always going to be cost. Okay, so this formula of net present value takes those stream of benefits or revenues, and then you just subtract the cost. And this is the cost if there is an upfront cost for the project that happens now. Okay, so you might purchase a piece of capital. It costs C sub 0 right now, and it's going to generate benefits in the future. Okay, and then there's several shortcut formulas, and the one that we'll use is the present value of a perpetuity. Okay, where a perpetuity is an indefinitely lived asset. Okay, so here CF is the cash flow. Okay, and if the cash flow, and this is the same thing as the future value, if the cash flow is constant over time, and you think you might receive that cash flow in perpetuity, basically forever, then the present value of this perpetuity is simply CF divided by the interest rate. And that's a real helpful formula. A lot of times, imagine you receive $100 right now, and you're going to keep receiving that every year. If the interest rate is 10%, 100 divided by 0.10 equals 100 times 10 over 1, or 100 times 10. So the present value of that perpetuity is $1,000. All right, so let's look at an example here. So you're in the market for a new refrigerator for your company's lounge. You've narrowed down the search to 2 models. The energy efficient model is $1,600, and you're going to save $45 in electricity costs at the end of each of the next 5 years. And then the standard model costs $1,400. Okay, so you're trying to decide which model to purchase, and you can imagine there's a big business firm that can be buying a bunch of these things, and so the decision might be pretty big. Okay, so assuming your operating cost of funds is 6% or the interest rate is 6%, which refrigerator should you go for? Okay, so to think about this decision, let's head over to Excel and let's calculate, or let's first set up the time period where we're thinking about. 0 happens right now. 1, 2, 3, 4, 5. Okay, so right now, let's see. We're going to calculate the net present value of the energy efficient refrigerator. So the benefit of buying the energy efficient refrigerator is the opportunity cost, or $1,400 for the standard refrigerator. And the cost of the energy efficient refrigerator is $1,600. Okay, and let's say the interest rate I is equal to 6%. And when you do this in Excel, you can do some sensitivity analysis and see how things might change at different interest rates. Okay, so I'm going to use the Excel formula for present value. The cost savings is $45. Savings equals. And so another benefit of the energy efficient refrigerator is the money that we're going to save every year. So we'll start with L5. We'll hard code that with those dollar signs and then divide that by the power formula, okay, which is not P3, but the power of 1 plus L6, that discount rate, raised to the power of J9, or the time period. Of course, I got that wrong. Plus the power of L5, there we go. Correction, L6, and then we'll drag that down for the future years. And let's compare the sum of the benefits, K8 through K13, with the sum of the cost. Okay, and so here it looks like the cost of the energy efficient refrigerator is $1,600 and the benefit is $1,590. So we would not purchase the energy efficient refrigerator because the benefits are less than the cost. We can take a look and see how the discount rate changes this. Let's drop the discount rate down to 0.02. So if we discount those future savings at a lower rate, we can find a lower rate to purchase those refrigerators on loan, then the benefit of the energy efficient refrigerators would outweigh the cost.